Okay, so we're going to start our last section of our text. This is additional topics. We're going to start with volume. Then we're going to go in to just converting some volume. We're going to look at mass and weight. The majority of the section is trigonometry, which goes into geometry at the very end. Okay, so we talked about area in the last section. This area describes a two-dimensional figure. For volume, volume describes how much space a three-dimensional figure contains. Okay, so we're measuring three things here. So thinking of maybe like a cereal box. You have a length and a width and a height. Okay, so you have three dimensions there. Okay, so converting metric measures of volume. This is the first thing we're going to do. It says common units of volume in the English system are the cubic inch, cubic foot, and cubic yard. Okay, so just like how we did area, remember for area we had square inch or square foot. This way we're going to do inch cubed or feet cubed, or this was yards cubed. Okay, so those are our units for volume. In the metric system, we have cubic centimeters, cubic meters, cubic kilometers, and those are all common. Okay, so it says find some equivalences in each system using linear equivalences. Okay, so again, we're going to do this just like how we did for area. Okay, so linear equivalence, that was just our one-dimensional, and this is what we should have memorized. Okay, so let's just look at, again, we know that 12 inches is the same as 1 foot. Okay, so there's our linear equivalence that we have memorized. And now we want to change this into units of volume. So what we're going to do is cube everything because every single unit is in cube. Okay, so then we want 12 cubed. Okay, so that's 12 times 12 times 12. Okay, which I'll need to get out a calculator for this. Oops. Okay, so 12 cubed is 1,728. Inches cubed, which would be inches cubed. 1 cubed is 1, and then we have feet cubed here. Okay, so there would be a English system volume equivalence. Okay, now let's go to the metric system. So let's do something like 1 centimeter is the same as, let's just go to millimeters. So remember we have the King Henry died Monday drinking chocolate milk. This first one is deca and this second one is deci. I just want to go from centimeters to meters. So 1 centimeter would be 10 millimeters. Okay, and we want to change this to cubic. Okay, so we would have 1 cubed, which is 1, centimeter cubed equals, okay, 10 cubed would be 3 zeros, and then we have millimeters cubed. Okay, so there's a volume equivalence for the metric system. So this is how we do equivalences for the metric system without having to memorize anything else besides linear equivalences. Okay, so first example, it says 5 meters cubed is how many cubic centimeters? Okay, so let's start with meters to centimeters. That equivalence first. Okay, so we want 1 meter is the same as something centimeters. So I'm just going to go back up to this. So we want meters to centimeters. Okay, so meters to centimeters would be to the right 1, 2 places. Okay, so to the right 2 places from this would be 100 centimeters. Okay, so we need to cube all of these. So that would be 1 meter cubed equals, this would be 3 sets of 2 zeros. 1, 2. So 1,000,000 centimeters cubed. Okay, you can check this on your calculator. Alright, so now let's go to the conversion here. So we're going to start with what we have. We're going to use dimensional analysis here. Remember, what we want to go away needs to be opposite, or in this case the bottom. Okay, and this is what we're looking at. 1 meter cubed is the same as 1,000,000 centimeters cubed. Meters cubed goes away. This would be 5,000,000 centimeters cubed. Okay, so this is a little bit harder than just our linear equivalence dimensional analysis. So we have this extra step over here. So just try not to get that confused. A lot of times I'll see students stopping at this step. You'll just put a million. But remember, this is just to give us the equivalence. Then we have to use that equivalence to do our dimensional analysis. Okay, next example, it says convert 4,320 inches cubed to cubic yards. Okay, let's do 1 yard. Okay, you should have this memorized. It's the same as 36 inches. Okay, so we need cubic yards and cubic inches. So let's go ahead and cube everything again. So this would be 1 yard cubed is the same as, okay, I'm going to have to use my calculator for this. So 36 times 36 times 36. So 46,656 inches cubed. Okay, so there's my equivalence. Now I'm going to do my conversion. So we start with what we're given. 4,320 inches cubed. Okay, then inches cubed go on the bottom. And then 1 yard cubed would be on top. Okay, inches cubed goes away. Here we're dividing. Okay, here we multiplied. Now we're dividing. This is probably going to be approximately. So again, I need to use my calculator for this. I got about 0.093, and that's yards cubed. Okay, so there's some volume conversions. Okay, so next we're going to go into liters. Okay, this is for the metric system. So it says in a metric system, a liter is a capacity of a cubic decimeter. That is 1 liter is equal to 1 decimeter cubed. Okay, so far we've done volume. Volume describes how much space a three-dimensional figure contains. This is a capacity. So a liter is a capacity, not volume. Okay, so liter is a type of capacity. Again, the most common is probably this 1 liter, and again, 1 liter is 1 decimeter cubed. Okay, the metric system works the same as it did for meters. So here we have King Henry. We have King Henry died Monday drinking chocolate milk. Okay, this is deca, this is deci. Okay, now instead of having our base unit as a meter, we're going to have this as a liter. Okay, so we have, okay, this is a kiloliter, hectoliter, decaliter, liter, deciliter, centiliter, and milliliter. Okay, so again, the metric system is very simple to convert. Okay, going on to page 2, let's just go ahead and do a simple conversion here. It says convert 27 liters to milliliters. Okay, so we're going from liters to milliliters. So let's go ahead and write out our King Henry died Monday drinking chocolate milk, but now we have liters here. And we're going from liters to milliliters. So we're going to be going to the right 1, 2, 3 places. Okay, so we're starting with 27, and we need to go to the right 3 places. So 1, 2, 3. Here's our new decimal. Fill in with zeros. So that is 27,000 milliliters. Okay, again, this is capacity. Our English capacity is gallons, quarts, cups, pints. Okay, in the stores you really see the metric system more. You'll see liters. So you'll see like a 2-liter thing of soda or something like that. So liters are what we use for the most part in applications. Okay, so next we're going to get into volumes of figures. Okay, so we know how to convert volumes or units of volume. So now we're going to actually look at figures and figure out their volumes. The first one is a right rectangular prism. The volume is length times width times height. So this would be something like a cereal box or an aquarium. You can also have cubes for these. This is still a rectangular prism. It's just every side is the same. These formulas you don't have to have memorized. You'll actually be given all of these formulas at the beginning of your exam. So any volume formula you'll need for the SAT will be given to you at the very first page. So you'll have to recognize that you have to find the volume, flip back to the first page, see the formula, and then be able to use the formula. So you don't have to worry about memorizing these, but you do need to make sure you know what each of these stand for. length times width times height. Down here we're going to have a radius and a height. So make sure you know what they stand for. Make sure you know what kind of figure it is, but you don't need to have them memorized. Okay, so first example, it says find the volume of the figure below. So I'm just going to go ahead and draw a rectangular prism. So I'm going to start with just a rectangle back here. This is going to look more like an aquarium. Okay, but I'm going to have a lid on it. So just as a box. Now I'm going to go ahead and change these to dotted. So for some reason I think it's easier to change my invisible lines to dotted lines for rectangular prisms afterwards. Okay, and I wouldn't see this back one. So all I'm doing here is just making the picture more accurate for you guys. So the lines that you don't see in figures, you want to do dotted. The lines that you do see can be solid. Okay, so that is an accurate picture. Okay, so let's say we have that this is 3 inches. This is going to be a small box. Let's have this be 5 inches, and then this is 4 inches here. Okay, so the height is 3 inches. Okay, so the volume is length times width times height. The length would be 5 inches. The width would be 4 inches. And the height is 3 inches. Okay, so we have 5 times 4, which is 20, times 3, which is 60. Notice that we have inch times inch times inch, which is inches cubed. Okay, again, that's a unit of volume. Okay, so that works. Okay, the next one we're going to look at is cylinders. So this for a cylinder, we have volume equals pi r squared times h, where r is the radius of the circle base and h is the height of the cylinder. Okay, so a cylinder would be like a soda can. I'm trying to think what else. Just really any type of soup can would probably be a better example for that, or a cup, a drinking glass. So a cylinder looks like this. So I normally start with an oval on the top, an oval on the bottom, but this one you'll do dotted here, and then you just draw lines here. Okay, so we have pi, okay, which is about 3.14. Then you have r squared, where that's the radius of the circle base. Okay, so here's the circle base, or down here, and then height would be this height of the whole thing. Okay, so we want to find the volume of the figure below. So let's say the radius is 3 centimeters, and the height is, let's do 40 millimeters. Okay, so we're trying to find the volume, which is pi r squared h. Okay, first off, we have a problem. We have millimeters and centimeters. Okay, so let's go ahead and change one of them. So just over here in the corner, King Henry died Monday, drinking chocolate milk. This is Decca, this is Desi. Let's go ahead and change the millimeters to centimeters, just because I don't like this 40. It's just a little bit harder to multiply. Okay, so we have 40 millimeters is the same as, so it says to take the decimal, move it to the left 1 place. That would be the same as 40 centimeters. Okay, so I'm just going to mark, 4 centimeters. I'm going to mark that off and put 4 centimeters. Okay, so filling in our volume, we have pi times r squared, so 3 squared. I'm going to go ahead and leave the centimeters too, just so you guys see the unit. Times our height, which is 4 centimeters. Okay, so I'm going to go ahead and leave the pi alone. So this would be 9 centimeters squared times 4 centimeters. Okay, so this is 9 times 4 would be 36, and then I'm just going to leave the pi. You can go ahead and multiply that out if you want. So times 3.14. I'm just going to leave it like that. And then we would have centimeters squared times centimeters cubed. Okay, make sure your unit always has a cubic on it for volume. Okay, bottom of page 2, we're going to move on to pyramids. For pyramids, we have volume equals 1/3 base times height. It says where B is the area of the base and H is the height. Okay, so be careful with these. The B is going to be the area of your base. Okay, so you'll be able to figure this one out. It could be a rectangle, it could be a square, it could be a triangle, it could be a trapezoid. So you'll need to make sure you find the area of your base first. Okay, so I'm just going to do a square base here. So make this. And then a pyramid just has a point at the top, and I'm just going to connect. Okay, so here's a pyramid. I'm going to go ahead and make this back line dotted. You wouldn't see that. Okay, so for this volume, let's go ahead and do an example. Okay, let's say this is a rectangle down here. Let's say this is 6 feet. Let's say this is 4 feet. And the height, this means the height is going to be the top of the pyramid, and it's normally to the center of your base. Okay, if it's not to the center, that means it's going to be opaque a little bit, and then you can't use this formula. So it has to be a right pyramid, which means it's going to be straight down into the center. So let's say this height here is 5 feet. So this is a 5 here. Okay, so we have volume equals 1/3 base times height. Okay, so volume equals, we can't do anything with the 1/3. Our base is going to be the area of this rectangle here, which would be 6 feet times 4 feet. Okay, times our height, which is 5 feet. Okay, so volume equals 1/3. We have 6 times 4 times 5, which is, I'm just trying to quickly do this in my head, 120. Then we have feet times feet times feet, which would be feet cubed. Okay, 1/3 of that is 40, I believe. So volume equals 40, and this would be feet cubed. Okay, so make sure you know that that capital B is going to be the area of the base of your figure. Okay, moving on to page 3, we're going to have 2 more volumes. Next one is a cone. Its volume equals 1/3 pi r squared h, where r is the radius of the circle base and h is the height of the cone. Okay, so a cone is almost exactly like a pyramid, except the base is a circle. So I'm going to start with an oval, okay, just because we're looking towards it. Okay, this is going to be the height. Okay, notice this is the same as volume for a pyramid was 1/3 capital B times H. Okay, where B is the area of the base. We'll notice that this pi r squared is the area of a circle. Okay, so for cones, we're really not learning anything else. It's the same formula for pyramids, except we have a different base. So we did an example of a rectangle. Okay, but now this is just a circle base. Okay, so find the volume of this figure. Let's say we have, let's just do a, let's say we're given a diameter of 10. Let's do meters. And then let's say we have a height of, let's do 6. Again, let's do meters. Okay, so our volume is 1/3 pi r squared. Okay, that's the volume of our base times the height. Okay, so 1/3, we can't do anything with the pi. Okay, the radius here, be careful, it's not 10, it's 5. Okay, because this is the diameter. We're given the diameter. Okay, so this would be 5 meters squared times the height, which is 6 meters. Oh, sorry, this squared needs to go on the outside. Okay, so this is 1/3 pi times 25 meters squared times 6 meters. Okay, I'm going to have to get out my calculator for this. So 25 times 6. Okay, so this is 1/3. We can't do anything with the pi. 150 meters cubed. Okay, then we want to do 1/3 of that. So that would be 50. Don't forget the pi, meters cubed. Okay, so there's our solution for that. Okay, and then one last volume. we have for spheres, volume equals 4/3 pi r cubed, where r is the radius of the sphere. Okay, so a sphere is like a basketball or any type of ball. So a sphere, how you draw that, I just start with a circle and then I have an oval in the middle, okay, where the back of the oval is dotted. Okay, so let's say we're given a diameter. Make sure it goes to the center for it to be diameter. Let's say we're given a diameter of, let's do 12 inches. Okay, so volume is 4/3 pi. Our r here would be 6. Okay, so then this is 6 inches. I keep forgetting my unit. 6 inches, and that's cubed. So I'm following this. Okay, notice the r is 6, not 12. Okay, so let's go ahead and cube 6. So 6 times 6 times 6 is 216. Okay, this is inch times inch times inch, which is inches cubed. Okay, so we're going to do times 4/3. Okay, which I got 288, so I multiplied by 8/3. We still have the pi, and this would be inches cubed. Okay, so that's just some examples of volume. There's application problems of volumes in the problem set, so make sure you look over those. They're a lot more difficult than this. And on the SAT, it's not going to say find the volume of a sphere. It's going to give you an application of it. So make sure you go over your problem set problems. It's going to give you a better idea of the problems that will be on the SAT for volume. Okay, we're going to go ahead and move on to complex numbers. We'll do complex numbers and then we'll stop for this video. Okay, for complex numbers, I equals the square root of -1. Okay, we need these complex numbers because if you have something like the square root of -4, okay, so you may get that as a solution. Okay, if you would type this in your calculator, it's not going to give you anything. It's going to give you not a real number or a domain error, something like that. Okay, so this gives us a way to actually compute it. Okay, so this will give us, okay, we know what the square root of 4 is. So let's go ahead and break this up. This would be the square root of 1 times the square root of 4. Okay, the square root of -1 is I, and then the square root of 4 is 2. So it would be 2i. Okay, so let's go ahead and look at the square root of -36. So we're going to do that exactly the same way. Okay, so square root of -36. So that is 36 times -1. Then we can break that up as the square root of 36 times the square root of -1. Okay, the square root of 36 is 6. The square root of -1 is I. So it would be 6i. Okay, for your SAT, I've seen these a couple times. Okay, so you'll need to know these base ones. Okay, and then I've seen on the SAT, like evaluate I to the 121. Okay, so you can easily figure that out if you know these, which we'll figure those out in a second. Okay, so what would I squared be? Okay, we have to be really careful with this. Okay, so I squared, okay, is the square root of -1 squared, because this is I, and then we're squaring it. Okay, so this actually ends up being -1, and this is by definition. Okay, so actually I think the SAT will give you this. They may just give you this one. I think they give you I squared is -1. Okay, so this is by definition, I squared is -1. I see a lot of times students will go, will say this is +1 because two negatives make a positive, but that is not the case here. Okay, so now since we have I is the square root of -1, and we have that I squared is -1, we can find all the rest of these. Okay, so something like I cubed, so that is I times I times I. Okay, we know that I squared is -1, so this would be -1. Then we have one more I, so this is -1 and this is I. So this would be -I. Okay, so I cubed is -I. Okay, I to the 4th is I times I times I times I. Okay, I times I is -1, so that goes away. And then we have I times I is also negative 1. Okay, so that's actually positive 1. Okay. Alright, so these are our 4 solutions. You have I, you have negative 1, negative I, and 1. Okay, so I to any power has to be one of these 4. Okay, so again, I to the 5th is going to be negative 1, negative I, or 1. It has to be one of those answers. Okay, so I to the 5th, that would be, I'm going to write this instead of writing out 5 i's, I'm going to write it as, that's the same as I to the 4th times I. Okay, well we know I to the 4th is 1 times I is just I. Okay, I to the 6th, that's the same as I to the 4th times I squared. Okay, so you just add exponents here. I to the 4th is 1, I squared is negative 1, so then I to the 6th would be negative 1. I'm going to go ahead and flip this over. Let's go ahead and do I to the 121. Actually, I have room on this back page, so top of page 4. So something like I to the 121. Again, this is going to be more like what you'll see on the SAT. Okay, we know it has to be one of 4 answers. It's going to be I, negative 1, negative I, or positive 1. Okay, so we want to write this in terms of I squared or I cubed or I to the 4th. Okay, well this is I to the 4th. How many times? So we have 120 divided by 4 would be 30. Okay, so 120 is I to the 4th 30 times. So I normally start with I to the 4th and see, okay, how many I to the 4ths can I get? And then how many do I have left over? So this I to the 4th to the 30th, that's I to the 120, and then we have one more left over. Okay, so I to the 4th is 1, and then we have I left over, so this would be I. Let's do one more like that. So again, when it has large numbers like this, I look at how many 4s I can have and then how many we have left over. Just I think that's the easiest way for me anyways. Let's do I to the let's do to the 99. Okay, so we want I to the 4th to some power. Okay, so if you do 99 divided by 4, it doesn't come out equally, but you can see that you can at least get 24 in there. Okay, so 4 times 24 is 96. So this gets us I to the 96th. Okay, then to get to the 99, we need 3 more, or I cubed. Okay, so this is I to the 96th and the I cubed, which would give us I to the 99. Okay, I to the negative 4th to the 24th. So this is 1 to the 24th, which is 1. Okay, and then I cubed, if you look back, which you guys probably should have these memorized, is negative I. Okay, so this would be negative I here. Okay, so I've seen these on most of the SATs I've seen at least one of these. So just make sure you understand those. Okay, a couple more things with complex numbers. Okay, it says when a complex number is written in the form a plus bi, where a and b are real numbers, the number is a complex number. Okay, so this I, okay, that's a complex number. Okay, but it's supposed to be written in this form, a plus bi, okay, where a and the b are real numbers. So for example, 3 plus 2i, that's called a complex number. Now I is still a complex number because that's the same as 0 plus 1i. Okay, 0 and 1 are real numbers. Okay, so this is a complex number. It just doesn't look like it. It's not written in this form, but it's still a complex number. Okay, so it says, example, find 3 plus 6i minus 2 minus 9i. Okay, so for complex numbers, we can only add and subtract when they have i's with them. So we're going to add and subtract the real numbers and then add and subtract what's with the i's. Since this is subtraction, I'm going to go ahead and simplify first. So 3 plus 6i, this would be minus 2, and this would be plus 9i. Okay, so minus and a minus. We have 3 minus 2 is 1. That would be plus 15i. Okay, so it's simple as that. There probably will be one like that on the SAT. So a simple problem, you just need to make sure you understand that you can only add or subtract the i's. Those are like terms. Next example, it says 3 plus 6i times 2 minus 9i. Okay, so now we're multiplying two complex numbers. We're going to use the same thing as we did when we were distributing. So we're going to multiply the first two. So 3 times 2 is 6. Multiply the last two. So 3 times negative 9i would be minus 18i. Then we're going to do 6i times 2, which is plus 12i. Then we're going to do 6i times negative 9i, which would be minus 54, and then we have I squared here. Okay, so this is, I'm going to go ahead and combine these like terms. So we have 6 minus 6i, then we have minus 54. Now I squared is negative 1. Okay, so we have 6 minus 6i equal, I'm sorry, this would be plus, I don't know why I had equal there, 54. So we have 54 times negative 1, and then this is a negative, so it would be plus. So the solution here would be, so these combine, these like terms, 60 minus 6i. So that's the complex number when multiplying together. There will probably be one like that on the SAT. There are a lot of examples. I believe it's in problem set 7 for these, so make sure you go over those examples. Next example, this is why I is important. It says solve for x and x squared plus 49 equals 0. Okay, so far we wouldn't have been able to do these, but now we have complex numbers, so we can. So we want to get the x squared by itself, so we're going to subtract 49 on both sides, so minus 49. Okay, now we will take the square root of both sides. That gives us x on this side, and then the square root of negative 49, which is the same as 7i. Okay, and then one more example, we have the square root of negative 32 times the square root of 14. Okay, so what we're going to do, we're just wanting to simplify this. Okay, so we're going to take the square root of negative 32. We know there's probably going to be an I somewhere here because we have the square root of negative 1. And I'm going to go ahead and write square root of 14 here. Alright, so let's go ahead and break up this square root of 32. We know we have a negative 1 in here. Now remember, when you have square roots and you're trying to simplify, you're trying to find perfect squares that go into these numbers. So our perfect squares are 1, which you don't want to use. 2 squared is 4, 3 squared is 9, 4 squared is 16, we have 25, 36, 49. Okay, so we're trying to find one of these numbers that goes into these numbers to break it down. Okay, looking at 32, let's start back here. 49 doesn't, 36 doesn't, 25 doesn't, but 16 does. So let's use 16. So 32 is the same as 16 times 2. Okay, so negative 32 is negative 1 times 16 times negative 2. So I haven't changed that at all. Then we have the square root of 14. Okay, do we have a perfect square that goes into 14? No, we do not. Alright, so again, let's break this down. So this will be the square root of negative 1, I'm breaking this down here, times the square root of 16 times the square root of 2, and then we also have the square root of 14. Now let's go ahead and simplify. The square root of negative 1 is I, the square root of 16 is 4, so we'll have 4i here. We don't know the square root of 2, we don't know the square root of 14, but we can go ahead and combine that. 2 times 14 is 28. Okay, so this is the simplest form here. So 4i times square root of 28. Let's just make sure and check that this 28 doesn't have a perfect square. Let's start at 25, no, 16, no, 9, no, and 4, also no. Wait, does 4? Yeah, 4 does go into that. So we can break that down. Yes. Sorry, I don't know why I said no there. So this actually isn't the simplest form. That is not the solution. So this would be 4i times the square root. 28 is 4 times 7. Yes. Okay, so then I'm going to come down here. This is 4i. This would be the square root of 4 times the square root of 7. So we have 4i. The square root of 4 is 2 times the square root of 7. So this would be 8i square roots of 7. Okay, so that was a long way to get from here to here. Okay, but there probably will be one like that on the exam also. So just be aware of that. Again, on problem set 7, which you're going to go ahead and stop and do that problem set or practice set, there's a lot of examples for complex numbers on those. So make sure you go over those and make sure you understand. Okay, so we're going to go ahead and stop there. The next video, we're going to start with mass and weight. And then depending on time, which we'll probably have time, we'll go and we'll start trig.